Alright, this is the last video calculating molarity. We've completed example 2. This time we're going to do example 3. We're using grams and milliliters. So I have this larger right here. Again, this is equal to big M. Our formula, if you like it better written like this. Alright, capital M, mole, liter. Those are the 3 things we need. For me, you're always going to solve for this. And I'm going to write this in a different color because if we look, this is not in the right unit again. So I'm going to have to do some work. And so we have this many grams of ammonium carbonate are dissolved to make this many milliliters. Now if you notice, that is not in liters. I'm going to do that one first. You should know by now that 1 liter is equal to 1,000 milliliters. Therefore, I'm going to put the 1,000 on bottom. Cancel out like terms. Liters. And I'm going to circle that. Right. Here I have ammonium carbonate, sorry. Now, back here, we got to figure out ionic or covalent. One of these is made out of metal and non, and these are made out of non-metals for the most part. If we take a look here though, ammonium is a bit awkward. Like I won't find it on the periodic table, but the ending here, carbonate, ATE, should be giving you some ideas, right? So this ending is for polyatomic ions. Right, we end in ate or ite. So if it's polyatomic ion, it's got to be ionic. I'm going to do symbol and charges over here. Ammonium is NH4, 1 plus, and carbonate is CO3, 2 minus. I'm going to rewrite these underneath. And I have to do crisscross. So this 1 is the digit of the charge. It becomes a subscript for the other ion. And so 1 to 1, and this digit of the charge becomes a subscript for this ion. So I get NH4. I need 2 of those because of the 2, so I have to put the polyatomic in parentheses, CO3. If you don't know how to do that, you want to review those videos. Now we need the molar mass of this because I got to get it out of grams. Right. I have 2 of these. I multiply. I have 8. I have 1 and I have 3. 14.01, 1.008, 12.01, 15.99. This one I know. This one I know too. I'm pretty sure about that one. $47.97. Alright, I know I'm going through this pretty quickly, but this is old and I'm just calculating a molar mass. You should have done several of these by now. That's how many grams are in 1 mole. Right. If you don't know how to do molar mass, that looks new to you, you definitely want to get that taken care of. So this is grams of NH4 to CO3. And I'm going to multiply this by 1 mole. NH4 to CO3, it's a long one, 9606, 4 grams NH4 to CO3. I know it's a mess. The Sharpies. Cancel out your like terms. And I can have 3 significant digits. So I got, what did I get? I got 9.91 mole NH4 2CO3. Now I have everything I need. And I know that was a lot, but none of it's new except for this part I'm just about to do. This is the only new part. Everything else is something that you've already learned. I can have 3 significant figures, and I got 5.66 big M NH4 2CO3. This is a very typical kind of problem because in the lab you usually measure things in milliliters and in grams. Alright, so there we have it. That is calculating molarity when you're provided grams and milliliters. Right? Do keep in mind that converting from grams into moles is an old skill that you've already learned. This one we did in the beginning of the year, the relationship between your different metric prefixes and how to convert. How to figure out if something's ionic or covalent is also something you've already learned, and doing crisscross to get your formulas. Don't forget parentheses around polyatomic ions, molar mass. Alright, so there you have it. Grams and milliliters used to calculate molarity.